So today I'm going to talk mostly about what we are seeing in terms of changes in climate, not in the Sierra foothills, sorry, in California in general, about temperature, precipitation, extreme heat, extreme events, snowpack, and how those changes are impacting our agriculture. Either it's yield, either it's season change, or pest pressure, etc. And then the remaining talks will talk more specifically about various other aspects. So let's start with some short-term variabilities. So this is the outlook which was from yesterday for 2 weeks ahead. So all this green means we'll have wetter than normal couple of weeks. The bottom one is temperature outlook, and all this cool area. And in darker blue, it doesn't mean that it's going to be even colder. It just says that temperature is going to, there's more confidence or skills in saying that we'll have cooler than normal couple of weeks. What you see here is 3 months outlook. So, and as you can see, California is completely white, which means it's equal chances of being warmer or cooler. So, your guess is as good as mine. It doesn't say anything about whether we'll have increased cooling or warming in that 3 months period. Well, this is an advisory. It's related to El Nino and La Nina. So far, we have been in a La Nina conditions, which typically means that oceanic temperature was cooler than normal for consecutive period of time, and we had been in this phase, but now we are moving more into El Nino phase, and so there is a greater likelihood that next year is going to be an El Nino year. What it means for California, there is a lot of obviously with atmospheric interactions, you always have those complexities, but in general with El Nino you might expect wetter than normal conditions in the southern and southwestern part of the United States. Okay, so let's talk about long term. This is changes in temperature across the state in last 100 years. So these are actual observed temperature changes in last 100 plus years. So this time frame is from 1895 till 2017. And if you see Central Valley, which San Joaquin Valley or Sacramento Delta region, the rate of increase in the minimum temperature, which is the blue bar, is substantially higher than the maximum temperature. So if you look at San Joaquin Valley, the minimum temperatures rose up to about 3.5 degrees Fahrenheit as opposed to maximum temperature, which was less than a little bit more than 0.5 degrees Fahrenheit. So this is observed changes in minimum temperatures and maximum temperature and the average. If you see the Sierras, there is a substantial increase in the minimum temperature in that region as well, and there are a lot of consequences related to increase in the minimum temperatures and how it can affect agriculture. So what we saw was the historical average. This is the projection. So what we might expect in terms of the temperature in the future, and this is only showing few models. What I wanted to show is that it's kind of upward trajectory for temperature changes under future climate. So this is state average again, and average for 1960 to 1990, 30 years period, temperature average is about 70 degrees. In the future, we'll expect about 8 degrees increase in statewide temperature. If you think about Central Valley or Merced, this average is roughly about 75 degrees, and increase is going to be about 83 to 84. So there is that gradual change, but I think the change what you're seeing at the statewide reflects the changes in different climate zones in California. Precipitation. So this upward figure, all this greener area means what it shows is last 100+ years has been wetter than normal. And as you can see in the western part of the United States, it was roughly slightly drier than normal, and parts of it still had some wetter conditions. If you think about the projections here, I see no trend here. What I see is a lot of variability, and this year is a perfect example of it, right? So, we'll expect to be drier extremes and wetter extremes at more frequency under future climate.
And that includes snow and rain?
Yes, that includes snow and rain, yes. So they transfer into the rain equivalent in this, yes. And again, this is statewide, and so if you capture for different regions, you might see different thresholds here, but it's hard to see any trend in any region. What the more confidence is in saying that our entire wet season is going to shrink. So even if we get same amount of rain, it might come in a shorter duration. So you'll have more extreme type of precipitation events could happen. Extreme heat is another big factor, and this is example for Merced region. And extreme heat is defined as the extreme threshold, which is a 98th percentile of the time frame you're looking at. So in this case, 1960 to 1990, sorry. And what it's saying that the threshold is about 101 degrees for Merced area. And so on an average, you would get about 4 days in that historical time frame where temperature exceeds that 100+ degrees. Under future climate, 58 days. So there is a huge increase in extreme heat conditions in the valley. And what we see in Merced, it represents the valley as well. So other parts of the Central Valley, you would expect a similar type of numbers and trend. And in terms of the timing of extreme heat days, most of the extreme heat days were concentrated in June, July, and August. As you move into the future, so it would start, in mid-May and last up to September and October. So, and I think the summertime becomes denser, which means that you'll have more extreme during summer, but it can start as early as May and can extend as long as September or October. Warm night, it represents the minimum temperature again. So I think what it says is when temperature at night, it captures the number of days when temperature exceeds 68 degrees for this area. And as you can see, there is clearly upward trend in warm nights. And there is a agricultural consequence of, when you have warm nights. Okay, I have 5 minutes. So when you have warm nights, you increase your respiration process more, and that affects crops. And it's in a more general sense, but it affects a variety of crops in a variety of different ways. Okay, so let's talk about impacts. When it comes to impacts on yield, this is only talking about some of these annual crops where there is a modeling data available and analyzing these results. What it shows is the impact only because of temperature increases. So there is no water stress included here. There is no management included here. I wouldn't look at the percentage for its value. What's important is the trend, and then see what sort of impact temperature increases can have on different crops. The problem with orchards and perennial crops is there is a lot of gap in terms of modeling those orchards and coming up with those type of impacts. So there is some research gap there. There are some advanced models available, but I haven't seen those kind of impacts talking about the future climate. Well, one aspect of orchards is chill, and that relates to the minimum temperature that we talked about. Under future climate, you'll expect less amount of chill accumulations. What this figure shows is changes in the chill portions, and as you can see, in 1950, so 70 to 80 chill portions, and under future climate by 2099, you'll have roughly 30 to 40 chill portions. So depending on different crops, you'll have that vulnerability. And this paper, when we did this study, we looked at the chill portions and chill hours. What it shows is the gradual decrease in chill hours as well. There is reduced frost exposure. So that's one good aspect, not the good, but at least the under future climate there is less and less frost exposure. So that's something to in areas where frost sensitive crops were not possible, now it is, and on an average there is 30 to 70% reduced frost risk in those regions in California. So length of the growing season, last spring freeze is shifting. Last spring freeze is shifting earlier, fall freeze is shifting later, and you have longer frost-free season for growth. And then this diurnal temperature range, which is a difference between the maximum and minimum temperatures, is also shrinking. Another study, what we looked at was time from planting to maturity for different crops. This is just an example of annual crop is tomatoes in this region. What we found is that time frame is shrinking, which means that that there could be adverse impact on crops. When it comes to temperature, there is a potential impact related to weed, pest, and diseases. So when you have temperature increases and then you have elevated CO2 conditions, it increases the weed pressure, which competes with the crop. Similarly for pest, and there is another pest presentation happening, so I won't go into the details. But these are the real challenges under climate change for agriculture. So the navel orangeworm, Jalendra is going to talk about this, and so I'll skip this for now. And this is my last slide. So in summary, changes what we are seeing is evident that it's impacting agriculture already. And so I think we need to be proactive. And I think the whole point about organizing this workshop and kind of promoting some of this climate smart agriculture, because it's not only improving profitability, but it's also like making agriculture more resilient to climate risk under long-term conditions. And I think if we produce research, we need to do this communication. So I'm glad that we are starting with nut production in this region, and I'll stop here. This is my contact information. Feel free to contact me anytime.